Hi guys, this is the first video for section 1-2, and this section is about graphs of equations. The objective for this particular video is to be able to graph equations by plotting points. Okay, so first of all, point plotting in order to construct a graph is not the ideal method. It's tedious and time consuming, and a more complex graph would require you to plot a whole bunch of different points to get an accurate graph. So it's not ideal. On the plus side, it always works, and it's something that you're probably comfortable with. However, unfortunately for you, after this chapter, point plotting will be safely tucked away, never to be used again. Alright, so basically when it comes to point plotting, we start off by making a T-chart. Choose some values for X, and then plug and chug. Plug that value in for X and get the value of Y out of it. After that, graph each ordered pair on actual graph paper. This is what I don't want to see. This right here, that's what I don't want to see. What's wrong with this? Well, it's handmade. Lines aren't straight, so that's a problem. I have graph paper for the purpose of making graphs on. Why make your own? Second of all, the lines aren't numbered. It's tiny. How am I going to get anything on this dinky matchbox sized graph? So that's a no-no. Do it on actual graph paper. Make sure that each graph has numbered axes. Now you don't have to number every single line. Every second line might work. Every third line depends on the graph. And don't add your own lines to the graph. If the lines that are there go up by 2 and it's numbered as such, that's all I need. I don't need you to draw actual lines in between each of them. Just use the graph paper as it is. If the points happen to show a curve, you need to draw a smooth curve. In other words, don't play connect the dots. For example, suppose that you have these dots right there. Okay? I don't want you to connect them like that. I want you to draw a smooth curve through them. And it might even look like kind of a sketch like I have on there. Okay? So don't play connect the dots on those. Alright, so let's start off with a simple example. Y equals 3 plus 2x. Now, by now you guys know that this is a linear equation. It means it's a straight line. So there's not going to be any curves. So for simplicity, we should choose small, easy numbers for our x. What's the smallest, easiest number to work with? 0. So we're going to go a couple numbers on each side of 0. So we go from -2 to +2. Okay, so now we plug those values of x into the equation. So if I plug 2 in right there, I've got 3 plus 2 times -2, and I get -1. We plug -1 in, 0, 1, and 2. Okay, so now I have the coordinates for this particular equation. So now I just graph it. And that's what it looks like. So notice on this particular graph that it's exactly as I mentioned before. You don't have to number every single line. You can go by 2s or sometimes 3s. Maybe you want to go by 5s if it's a very big graph. Okay, so that's point plotting for a straight line. How about this one right here? This graph is not linear, so what kind of graph do we call this? Think about it. Think about it. That's right. It's called a quadratic. And it forms a parabola. Well, we could stick with the same small numbers that we used in the last example, but we will end up with a slight problem in that case. But let's start. -2 to 2. Alright, so if I plug -2 in here, I have -2 squared. And a -2 times that is a -12 and a +7. So, what do I get? -1. -1 gives me 2. 0 gives me 7. 1 gives me 14. 2 gives me 23. Now, if you recall what our last graph looked like, it only went up to 10 in each direction. So 14 and 23 are going to exceed our graph, but that's not where the problem really comes in. To understand the problem, we need to actually look at the graph that we have so far. Okay, the points look like that, and you can see that there's a slight curve to it, but we do have a problem in that we don't have the entire picture. We only have part of the right side of the parabola. We don't even have the vertex, and we don't have the left half of the parabola. So the solution to that is to plot a few more points on the left hand side. So if I started at -2 and I want a couple more points or a few more points to the left, how about -3 and -4? And when I plug those two in, I get the following values. A -1, and I've already put the point in there. And now you can kind of see where the vertex is supposed to be. When I plug 3 in, I get -2, which is right there. So that alone should be enough to complete our graph, because the left-hand side of a parabola should look just like the right-hand side. And so it looks like that. Now, pay attention to whether or not you have enough information to make an accurate graph. In that last example, I had to choose a couple more points to get it to where I needed it to be. So, that is plotting points. That's it.